Hello.
Hello, yes, sir. We will start at 5, sir.
Okay.
In 3 minutes.
Sure. You can hear me, right?
Yes, sir.
Okay. Let me share my screen.
Hello, Karthi.
I don't know.
Karthi, can you just share your screen? Just you
Yes,
want
I'm doing that right now.
I can now we can see you. Yeah, we can see your presentation. Yeah,
Okay. Is that okay? Can you
yeah,
all
it's
see my
okay because
presentation?
I am sharing the screen, so that is why I think you will not be able to share. So for the time being, no, up to the introduction, no, I'll be showing you. I'll be displaying my presentation to the participants.
Okay.
So I'll be sharing my screen.
Oh, you want to share your screen? Okay, I'll stop
Just
sharing.
introduction. While the introduction, I'll be presenting about it.
Okay.
Yeah.
So you're going to share the screen, or I
No,
will
you
share?
sharing your screen. So we'll just no. For the time being,
Okay.
kindly wait.
Sure.
Sir, can we begin?
Sure. Yeah, I'm ready when you're.
We can
Sir,
start.
yes, sir.
Yeah.
I'll start. Good evening, everyone. For our concluding session of the International Virtual Workshop on Advancements in Design and Material for Product Development, I'm very pleased to welcome our next speaker, Mr. Karthi Punyaraj from Ontario, Canada. He is currently working with Toyota Motor Manufacturing in Cambridge, Ontario. He completed his undergrad in mechanical engineering from Anna University and then his master's in industrial engineering from Louisiana State University. His professional achievements include conference papers in assessment of impacts of merge configuration, traffic density, and distance between traffic signs near freeway work zones on driver response. With an expertise in process planning, commercial and business feasibility study, layout planning, lean manufacturing, and vehicle assembly, he has garnered more than 5 years of experience of project management in the Department of Vehicle Assembly, which is also the topic for his today's presentation, as he will be sharing his expert opinions on project management for assembly equipment. Please, sir, you can take it from here with your presentation.
Hi. Thank you all. Hope you can hear me very clearly. So if you have any issues with hearing or seeing my presentation, please let me know in the chat box. Thanks for the opportunity. I hope I can give some small highlights about the work profile of project management. It will not be more technical aspects into this presentation. It's more like management stuff and what you'll be doing for process designing. Basically, it's not like a product design or a software or anything that you will be using, or I'll be giving any highlight, but it's more like process designing and eventually going into a project management profile. So basically, for any students, when they start as a process planner or product designer or process designer, and then they grow into a project management field as a project manager. So I'm going to basically talk about that and cover more on the process design aspect in this presentation. So I'm going to share my screen. Okay, hope you all can see my screen.
Yes, sir. Yes, sir.
Okay. So as I said, project management for equipment is my topic for today, basically focusing on process design. So my agenda today is to give a small introduction about the whole scope and what is the presentation is about, and talk about the project management profile. Basically, what you'll be doing in the project management when you take that role in future, and more emphasis on process and equipment design elements in a project, and followed by questions and comments. So this is basically my profile. I started working in TVS Sundaram Fasteners for about 1.5 years as a process planning engineer. That's how I started my career. Then moved to Bosch Limited, where I worked for 4 years as assistant manager project management. Then moved to Louisiana State University to do my master's degree in industrial engineering. Then started working in Toyota. I'm currently working in Toyota for 5.5 years now, and I'm into project management as a project manager. Okay, so more as a scope of presentation, hope this is the last presentation for the day. I don't want to give so much technical details or more emphasis on a lot of other details. Consider this presentation as a project management overview and basic management principles, right? So scope of this presentation. So in any organization, you will have a design department, or design or product development team who will design the product, basically, right? For example, a door of a vehicle, right? So they design the product, they develop the product, they make concept designs, they make final product, and then there is another team where they handle all these projects, like project management team. What they basically do is they will try to build some equipment with which these products can be used, or these products can be used in the assembly line, or carried away, or try to make this product into a final product for the customers, right? So there are a lot of equipments involved in a shop where you use this equipment and for example, lift this door and then set it onto a different carrier, and from there you start assembling the door, right? There'll be like hundreds of equipment in a assembly industries, right? So this project management team basically takes a project, executes it, and then hand it over to production department, right? So they get the design data, concepts, and final product from the product design team, and then make some specification, make some concepts and ideas, and then send it to equipment manufacturers, right? Sorry, I'm getting a call from Renault. Okay, so basically these specifications will be given to equipment vendor, and then equipment vendor builds the equipment, make it as a working equipment, and send to production and maintenance team. So considering this whole scope, just think about like you're buying a TV for your home, right? So basically you will see what kind of TV you want, what spec you want, whether like 60 inches is fine, 70 inches is fine for your home, and whether it will fit in your space. And then you decide, okay, I'm going to buy this kind of brand, and then I'm going to install this TV into the home and make it work for everyone, right? Work for everyone's height. So basically, even that is a project management, right? You see each and every activity in your home as a project management. You can still see it that way. It's like a one-time activity, right? You just take that process, execute it, and then hand it over to person who are going to use that. So our focus will be mainly on equipment and process design in this management scope, right? So that's how you engineers will also start your career. Like you'll start with technical aspects of process planning, and then getting into a project management field. So in this presentation, let's take this one door as an example. So in equipment assembly or vehicle assembly process, so we'll have the shell body of the vehicle coming into the assembly shop, and we have to take this door out and then send it to door assembly process, right? So let's say we are going to build this assist. So this door will be heavy. So one operator, let's say one team member, cannot lift this door, right? So they need to have an assist that can help them lift this door and then send it to next process. So let's all assume that we are in a project assembly department now, and then we are going to build this equipment, right? So what we will receive from design department is the design of this door, concept of this door, or maybe a concept door, like maybe like a concept vehicle door, right? So we'll get that information from the design team, and now we are going to write a specification for an assist that can pick and load it to the next station. So that's our job. So that's, let's say we are just breaking down into a small project, right? So let's say in assembly like this, there will be like more than 50 or 60 equipment, right? So for example, we are going for a big design change, right? From one model of a Lexus to a next model of Lexus, let's say. So we may have to modify or buy like 50 or 60 equipments, right? New. So this is how we start a project management, and then move forward, make it work, and then hand it over to production with some studies that we do, right? So hope you all are clear. I'm up to this point, right? Scope of the presentation is clear. Okay, I'll take that as a yes.
Yeah, yes, Karthi, yes.
So project management. So let's say for this lift assist, that's what we are going to talk about. So it's a very temporary endeavor. Like it's not like a regular activity. It's like one-time unique activity that we are going to do. It will have a defined beginning and defined ending. So it's just basic project management principles, and it is very unique for that particular operation, not a routine operation. You just start that project, take it, implement it, and hand it over to production, right? Your scope ends right there. So project management has like different phases. Like you initiate a project, you plan for it, execute it, and you monitor for some time, and then you close that project. So project management phase one. So there are different kind of projects in industry, but most commonly, most of the projects will fall under these categories. So first is the localization project. So for example, in our case, let's say we are buying this equipment assist, right, for the door. So first we have to think whether we can buy it locally made. Like for example, if you're going to buy it in India, some vendor can make it in India. So you do that as a localization project. So for example, you may have a company, you may have a branch in, let's say, Germany, or you may have a branch in US or somewhere, and they will be making the exact same product, exact same assist will be there. So you basically take the design, try to localize it and make it work for local people. So then it's called localization project. So there is a next type of project is relocation project, right? So you have a setup already in a different location. So you're going to basically relocate that and make it work for current shop, like in India, for example, right? And then you do a kappa project where it's basically like you already have a setup in your assembly shop. You can make, let's say, 500 vehicle a day. You're going to make it to, let's say, 1,000 vehicle a day, right? You're basically increasing the capacity of the shop. So that's another type of projects. So what basically you do is you just add some equipment, or maybe increase the capacity of the equipment, or reduce cycle time. Sorry. Okay. So next is the model change project. So for example, as I said, like let's say you have Lexus RX 450, and then you're going to a different version, or maybe you have a Corolla and then you want to change it to RAV4 model, right? So you're going to do a product like complete model change project. So as I said, like Corolla project, right? Let's say Corolla has different set of doors, different look, and different size, shape, and everything. The next RAV4 comes into the same line, and you have to modify the whole equipment to make it work for the new RAV4 model or the Lexus model, right? So basically all the equipment have to be changed, and new equipment needs to come in. So you have to make the line work for that new project. So that comes under model change projects, right? And then you go for, there is another type of project where you do just procurement, right? So you have a location in Germany and you have location in India. Basically, all you do is just buy from Germany and sell it to local customers. So that's another kind of project that you can deal. So mostly in any organization, if you go, your projects will fall under one of these category, right? So once you know what type of project you're going to do, you basically do a project feasibility study. So project feasibility, there are basically three kind of feasibility you will see. So first is business feasibility, right? Let's say in our example, like you have a company in Germany, you have a company in India, and let's say China, Japan, right? So you basically in business feasibility, what you do is, if we make this vehicle or any product in China is cheaper, or in India it's cheaper, or in Germany you make it and then sell it, which will be cheaper option, right? So as a business aspect, you will see which location basically is feasible for us and it's more profitable for us to do the business. So once you know business feasibility, you go into commercial feasibility. So where you basically see, okay, let's say if we do it in India, whether the money, like let's say we have to invest like 10 million Indian rupee or in Canadian dollar or whatever, right? You're going to invest that much money, and are you going to get that return back? Whether we will be commercially feasible to do that product in India, right? So that is the next level of feasibility. And then you go for technical feasibility. That's where you engineers will start your career, technical feasibility study, and you'll be the process planning person of any company if you take that career and moving forward, right? So once all these three feasibilities done, okay, we found out business is feasible commercially, we can do it in India, and then let's say technically it's possible to do it here. Then you go for project agreement. That's when you start a project. That's when you initiate a project, right? So basically, in that agreement, you just sign off the business. So okay, all these three locations we decided India, and then we are going to sign off that agreement for India, and then the commercial agreement is basically like the big money, right? Like, okay, I'm going to give this much amount of money to India, and then they're going to make that product there, right? So that agreement will be signed off, and then you just write down the scope of the project, basically. So what will be the scope and what all we will be doing and what all we will not be doing in that location. And then you set KPIs, key product project indicators, right? So you're going to set all those key indicators and then stick on to that and not deviate from that KPIs. And you set a major milestones. Okay, at this year we'll do this, at this date we'll do this. You set a milestone and then sign off the agreement. So that's where the phase one of project management completes. So this is basically it covers all the commercial aspects and also a little bit of technical aspects onto this. I like this project management profile very much because it has like a mix of everything. It's not just like you're focusing on one particular software and designing it or doing some technical aspect only on that particular thing, right? So this one focuses on like all variants. You'll be interacting with like 100 people down the shop and then going to vendor location, doing like different business feasibilities and all those things, right? It'll give you a very broad scope and then a very good idea about diverting your career into different paths, right? You can then choose on which one you want to specialize and which one you want to focus more on to, right? So for this presentation purpose, I just want to focus on this technical feasibility aspect. And more in the phase 2 and phase 3 of project, I'll just focus on the technical feasibility and process designing. But I wanted to give you a profile image so that you guys can be, if someone is interested into taking into this career, you can just keep this in mind, right? So in technical feasibility, we are going to take this example assist to lift the door. So I'm not sure, I'm not blocking this. Okay. So in technical feasibility study, the first step is, let's say I want to make this assist. I want to see if this assist can even fit into my shop, right? So you'll have a small space.
Karthi, sorry to disturb you, sorry to interrupt you, but we are not able to see any presentation. We are able to see you. We are not able to see the presentation.
Okay, let me check. So from this screen, you stopped looking at, are you okay?
Yeah, we are now able to see the technical feasibility study.
Okay, I covered this, you saw this one. Okay.
Yeah, up to phase 1, we were able to see.
Okay, so I hope until now you are clear on what we are talking about, right?
Yeah, yes. Yeah.
Okay. I didn't check the chat box yet. I'm not sure if there is any questions from participants.
There is few questions, but we can take this at the end of the session so that the flow of the session will not be disturbed.
Okay.
Yeah.
Okay. Okay, so phase one is completed, and then we are going to focus on technical feasibility a little bit, and then move on to phase two. Okay, so in technical feasibility, the first thing is we are going to see if we even have a space to do anything, right? So first thing, what as an engineer, what you guys will be doing is you just take some scanning tools or take your tape measure. And trust me, guys, like you will use tape measures and steel rules and all these basic measuring equipment more than all these hi-fi technical like scanning tools and stuff, right? As a project engineers or project managers, you don't have to deal with all these things like scanning tools or design analysis tools and all those things. All you'll be doing is like managing people to get these things done, right? So, but you should also know all these equipments are existing and what is the functionality and uses and stuff. But it's just based on your interest. First thing, what you'll do is just check the layout whether you even have any facility to do the equipment, or can we even install the equipment here, right? So you basically do that with the scanning tools, AutoCAD, make some layouts and do a preliminary check. This is like high level check, right? Because it's a phase one, we have to even just say, okay, is this possible to do it here or not? That's all, right? And then you go for equipment and process list. So in our example, we just chose one equipment, right? But as I said, in an assembly line, you will have 50 to 60 equipment. So you have to list down all the equipment that need to be modified for a particular vehicle or a model change or anything. So you just list down all the equipment we need to modify or we need to buy new. So that checklist you will make. It's basic small Excel sheet checklist that you make and list down all the equipment with asset numbers and everything, right? Then once you're done with that, you go with the available concepts and designs. So as I said, the product design department will give you the concepts. They'll give you the design. It can be in CATIA or SolidWorks, Pro-E, AutoCAD, whatnot, right? There are tons of softwares outside. Basically, we use CATIA, SolidWorks, Pro-E in Toyota. So and they may also give some proto models to us, right? Depends on which phase of the project you are. So let's say, for example, a design change or a new model launch. So initially, we'll just get only 3D models of a vehicle, 3D models of a door, whatever, right? We just get in STP or CGR formats of, that's the most commonly used format that people share different files to different vendors or different location, right? So that with that information, you start checking, okay, I have this 3D model, I have this layout, can I even make this equipment work for this in our industry, right? Or in your plant or in your home, whatever, right? And then you go for modification or new procurement scope. So basically, as I said, in point number 2, you list down, let's say 50 equipment, and you have to decide, I'm going to buy new or I'm going to modify the existing one. So there may be some equipment like this working for 20 years. It can still work, right? You just have to modify that a little bit or reinforce it, and then make it work for maybe until next model change, like 3-4 more years, right? Or you may have to buy completely new and make it work for next 20 years. That's up to you. That's the decision that you need to take, brainstorming with production team members, production managers, and you need to do cost analysis, right? If I buy new, what will be my cost? If I modify this, what is the cost of maintaining it and making it work for next 10 years for next models, right? And also the equipment life. So all these things you take into consideration and then say, okay, I'm going to do this check sheet. I'm going to make it modification, make us a new equipment. And then once you're done, you'll be doing some Kaizen ideas and Yokoten. That's a term, Japanese term that mostly you will hear if you go into Toyota. So it's Kaizen is usually, as you might know, it's a small improvement. So basically, if you have any equipment in any different location or any other organization, you just take that idea and then start doing small improvements on that. So instead of like reinventing the whole thing again, you just basically take something and then improve on that. So that's how Toyota rolls, or that's how many industries rolls nowadays, right? Basically do benchmarking. And then once that everything is done, you just estimate cost of each item. So you decided whether you're going to modify or new. You had all the Kaizen ideas. You know what the equipment we need to modify, and then you just put some numbers to that. Get some budgetary quote from different vendors. You'll have so many vendors who can make these kind of assist. Just talk to them and then get some budgetary numbers, and then attach to that Excel sheet. So now you basically whatever you have in your mind with all the technical knowledge basically got into some numbers, and then with that sheet, if you go, you'll be basically done with your feasibility study, right? So this is where like you engineers, when you go into an organization, into manufacturing side, you'll be doing basically all these things for the first phase of the project. So once that is done, phase one is completed. So let's say we decided we wanted cap-up projects for new equipment, and then feasibility study is done. We decided profitable, commercially profitable, technically it's possible to make. And then project management signed off, everything, all these agreements signed off, and we are entering into project management phase two. So in phase two, first we start with budget approval. So we have a big number for us, and then we have to sort it down to a small number and more accurate number, and get it approved, right? So you may so let's say $3 million, you may have a project, right? And then they will not completely give you that $3 million. You have to put some proper numbers for every equipment, and then you need to go for approval, and there will be a lot of cuts for like you as an engineer, you'll be facing that when you get into organization, right? So let's say they'll give you $3 million worth of project, and then they will say, okay, you need to get it done in 70% of the cost, right? That's where all your technical capabilities and your working skill comes into picture, how to reduce the cost, right? So you put on all these lists and then get the approval from the management, from your management. And then once you get that much money, you start allocating into of your project into different scopes. Let's say in our case, only one assist, right? We just put that money into that assist. What you need for planning phase, what you need for procurement phase, what you need for a vendor, and what you need for later on, right? So every phase, you just allocate that budget, and then you establish a more detailed time plan. So initially you had timelines like milestones. For example, let's say start of production on 2021 May, for example, right? So from that date, you work on all your detailed timeline, and backwards. Basically, you just take the SOP and then work backwards, and then create all your micro level timeline, right? So once that is done, you write a modification or new specification. So in our case, let's say we buy new assist, we are going to write a specification for that. So specification in a sense, like how do you want the equipment, how it will look like, what color you want, what kind of a door it will hold, and what kind of stroke that assist need to have. So when I say stroke, so let's say you have a small door like for Corolla, and then later on in 10 years, you will have Highlander in the same line. So that assist have to have the capability to do both Corolla door and also possible extension for future, right? So you'll be writing all those things into your specification, like all those constraints and whatnot, right? Everything goes into the specification. So that's a very key aspect of any engineers, like they will be starting in their career, right? Specification. So you need to be very thorough on what you want. As like in project management side, as I said, you don't have to be like completely like technical in going into more specific details, but you need to focus on all the constraints that you have in your shop and what exactly you want. You need to be specifying that in your spec. And then once that spec is done, you go for bidding process. Basically, you take the spec and go to 3 different vendors, or like maybe 10 different vendors, and float your quote. This is basically to cut down costs, right? So when you bid, you basically cut down costs from different vendors. So if you just go for one vendor and ask him to make this, he'll give you like like a very good price on that, like very high price on that, right? But if you have like 3 of them sitting together, they will definitely have to come down, even though they are competitors, right? They will have to come down and give you a good price for that. And you choose one vendor based on that, and you do some engineering studies along with them. So once, let's say you choose a vendor, okay, this is a XYZ vendor is going to do this equipment, right? You have to do some studies. So this assist that we saw in our example, right? Like, so this, let's say this assist will be hanging overhead, right? So when it is hanging overhead, there may be like 50 or 60 equipment hanging overhead too in the same kind of structural element, right? So you need to see whether that structure is capable enough to hold this new equipment and it can take future equipment. So you have to do some studies, like for example, tab loading study, right? So whether that tab that steel structure which is above, whether it can hold that equipment. That's one example. And another example is whether this assist, let's say the door weight is like 50 kilograms, whether the assist can hold it, and what kind of stress points will be there on the assist. So basically for designing phase, right? So you'll see that in upcoming slides. So those kind of studies you have to do with vendors. And once that is done, you will have an equipment concept and design. So you did the bidding process, you did the engineering study, and they will come up with a concept. Okay, this is how your equipment will look like, right? And once that concept is done, you basically say, okay, I'm gonna go for a buy-off process for that design. Or even buy-off can happen during design process where you accept the design and then say, okay, go ahead and manufacture that equipment. So they fabricate it, and then you go to check, okay, whether they made it as per my specification or not, if there is any deviation or not. So you buy off that equipment and then you install it and try it out. So that's where the phase 2 of the project management comes in. So you have any questions until now? Is there any major questions that I need to check in the chat? Okay, so there is no questions, then I'll move on. So in phase 2, I'm going to focus mainly on new or modification specification, engineering studies, concept design, buy-off process, install, tryout, and handover. So these few things, I call it as a design elements of project management. And I'm going to split into 3 different categories: engineering study phase, specification phase, and fabrication and buy-off phase. So in these 3 phases, you will have some design elements. Like this, when I say design elements, it's like process design. Okay, so designing the process or designing the equipment. So first, we'll take the design element phase. So we are in phase 2 of project management, and inside that, we are going to do design elements in a specification phase, right? So when you're writing a spec as an engineer, you get into your shop and then you get into your Excel sheet and you're going to start making your specification, right? So first thing is you need to know your constraint. What am I dealing with? What I'm going to write a spec? You basically get all the constraints put into that spec. For that, you use, like, let's say 3D scanning. 90% of the time you'll be using these basic tools, right? Measuring tape, scales, and whatnot, leveling equipment. Take pictures, put some specifications together, and then all these 3D printing stuff. So we don't use 3D printed stuffs for any products, like final products, but some 3D printing stuffs are followed for trials and to test whether this particular part will go and fit into this. And so those kind of activities will be done with 3D printed parts. So that's how you find out, okay, this may be a right product for me, right? Then once you're done, you try to add all poke-yoke elements to that. So poke-yoke you might have heard many times from different subjects. So poke-yoke is mainly like foolproofing. So anyone who comes and works in that equipment or uses that equipment, they should not do any mistake. So you need, as a engineer, you should write a spec, or you should design. If you're a designer, you should design something which nobody can make a mistake, right? So you need to have mechanical control, pneumatic and logical control, and electrical wiring. So mainly like pneumatic, mechanical, and electric will be the 3 major thing on an equipment that you need to have proper focus on, and try to implement all the poke-yoke in the design phase itself. So once you're done with a good design, your equipment will be good enough for like 90% of the cases, right? It'll be safe to operate, safe to work. But let's say, like, you may not be able to design completely like 100%. You cannot put everything like foolproof. You may have to do some engineering controls later on, like for example guarding, right? Like you have a cutting tool, and then you may just have to provide a cover for that. So that's kind of engineering control. And then PPE comes into picture, right? If you cannot control in any way, then you use gloves or shield or whatnot to keep yourself safe. So once you put all the poke-yokes into that specification, you take some Kaizen ideas, or you take some Yokoten from different industries, or within your own organization, you may have a different equipment which will work exactly same like that. So you can take some elements from that and then put it inside for time reduction, right? Basically, you don't have to reinvent everything. It's all there. You just need to gather everything and then put your own mind and then just try to do some Kaizen activity on that. And another element on that spec is the ergonomic guidelines you might have studied. So it's basically like, let's say in Toyota, we have a standard like you should not lift more than 5 kilogram repeatedly for a shift, right? So if anything more than 5 kilogram, you need to have an assist. So if I'm going to lift this box, which is more than 5 kilogram, I need to have some kind of assist to lift it and place it in a higher spot here, right? So you have different guidelines. You have NIOSH, you have OSHA, you have different internal guidelines for any companies. So you need to gather all those things and then put that into your spec. So this is my guideline. This is how you need to design your equipment. So in our case, our assist, right? For our assist should not be heavy enough, like more than 5 kilogram when you operate the assist. So basically, it will all be controlled by pneumatic logic, right? You'll have a pressure cylinder which will compensate your lifting pressure, basically. So it should be less than 5 kilograms. So it should be very easy to take the door out and then put it onto a conveyor or put it onto the next process. So that's how the whole spec needs to be. And then you focus on cycle time. So what the vendor who is going to make that equipment, he should know, okay, this assist will should work for 55 seconds. So in 55 seconds, you just take that door and then load it onto the next process. So if he doesn't know that, then he just makes some equipment which will take like maybe 3 minutes, right? Which will not fit into your line. So you need to specify that. And then once that is done, you also say, okay, I'm going to do a process capability study for, let's say, 30 or 50 vehicle, and then prove that, okay, this is going to work, and I'm going to hand it over to production. So all these elements should be in your spec and followed by your risk assessment. So risk assessment or FMEA, failure mode effective analysis, you might have studied. Basically, you predict what all possible risks are there in using this equipment and how you can mitigate that. So this is during the specification phase, right? You're assuming things. Okay, this is how the assist will look like, and these are all the problems it may have, and these are the steps I'm going to take in the design phase. I'm going to rectify this in engineering control. I'm going to do this, and after that, I'll use PPE to control all these risks, and then put everything together and send it to your vendor, right? And risk assessment is a live document. You keep on updating at different phases. So you update in design phase, and then once equipment vendor or whoever makes the product, they will have to revisit this risk assessment and make sure, okay, all these risks are covered. I have covered everything in the design. Okay, there are additional risks that I'm seeing from this equipment, so I'm going to add that. So they will update that risk assessment during fabrication timing. So once fabrication is done, we come and we do a trial in the shop, right? So during the trial, we will find additional risks, or the risk that we already listed out may not be even there, right? So we again update that risk assessment during that time. And then finally, during handover timing, we'll again review the risk assessment and then say, okay, there is no risk. All these risks have been undertaken. These are the risks that you need to manage with your PPE and other stuff, right? And then we hand it over to production. So this is a live document. You update at least like 4 times in a project. And then you come up with a timeline to the vendor. So this is like a timeline mainly for the vendor who is making you the equipment. So you write a fabrication time, and then material or process selection, whatever you want to put into that, you just put there and then make a timeline on that. Okay, so this is the design elements in a project during specification phase. So next is engineering study phase. So as I said, engineering study, first thing is you have to see whether you have fit form analysis, right? Whether the assist will even be able to lift this door or not. So let's say you have existing assist and you're trying to use that. So in that case, first you have to see, okay, whether it will fit, whether we can make it we can modify it for the new door, right? We can use 3D modeling tools for that. And then we do FEA analysis. So FEA analysis, vendors will be doing it. So they will see where the stress points will be in assist. Usually, let's say, for example, if you lift the door here, your stress points will be somewhere in this main arm, right? So they will see, okay, whether this stress is capable enough or we need to reinforce it to make it work for next 20 years for this heavy door, right? Then they will decide the equipment life. These are all like it's a very predictive FEA analysis. It's not like a hard and fast number which you will stick on to forever. This is like an estimate, right? you need to have some kind of estimate to move forward and say yes to the fabrication team. Okay, make this assist, right? You cannot simply say, okay, this is my sketch, I'm gonna move forward and make this equipment. So you need to have some kind of documentation that say, okay, this will be fine. Okay, this has like, let's say 20 years life, and these are the reinforcement points, and this is the design that I'm going to make, right? And then once that is done, when you hang, as I said, whether the hanging structures, like the structure that hangs on to, whether it is capable of that load, and you'll have a tab loading study done during that time. And once everything is done, you will see if we can make a prototype out of that. So in our example, they won't make any prototype because it's like assist. We cannot initially make a big prototyping and then try to test it. But for small parts or small equipment, we can try to make like 3D prints, or maybe some crude other process, like with different aluminum or maybe wood or something like that. You make a prototype, right? And then try to see if we can use it. And then once that is done, you do a simulation study or live study. So in this design phase, you do the simulation study and then see where the stress points are. But once you bring the equipment into the shop, and then you have the physical equipment, you basically do a live study. So in live study, what they do is they take a strain gauge and attach into different spots. Let's say you have 6 spots where you need to check the strain gauge. So you attach that and then read the actual values, right, when the equipment is working. So basically, you're comparing FE analysis during design phase versus actual. So that's where the whole engineering study gets closed. You do a study initially, and then make sure that it's good in the real time scenario, right? As I said, like we also use some 3D prints to do some studies, right? So that's where the engineering study phase ends, and then you have another design element during fabrication and buyoff process. So now all the design is done. So equipment is fabricated by the vendor. So you're going for a field check. So basically what you're doing is whatever design they gave, and actual, whether that is matching or not. And then you go with the buyoff checklist or Kanban. So we call it Kanban. It's always a pull system. If you get into Toyota, you'll hear like a lot of Kanban process. So it's basically, it's like it can be like any card, like a small card that says, okay, I want this part, right? Or a checklist. It's a different form of Kanbans available. So we use that checklist and then check mechanical checks, pneumatic check, electrical logic check, circuit checks, and safety checks. So there are like 100 or 150 checklist items that you will basically check and make sure the equipment is made as per your specification. If not, you put it into an open item list, right? So I wanted like 100 things. They could not make like these 2 things, or maybe there is a deviation from my spec. So you just put that into open item list, and then you go to your stakeholders. Basically, stakeholders is your next customer, right? Like we are all now project engineers, so we are going to, let's say, to the production guys, production management, right? And ask, okay, we wanted this, but we cannot get this in the equipment. Do you guys agree? Is it okay for you? Can you manage, right? So they will say, okay, no, we want this, or no, we have to modify this. You have to get that agreement from them and get a sign off. And then once they agree, you bring the equipment from the vendor and put it into your shop and do an actual trial with the actual part, right? Once that is done, your responsibility is to test for 30 parts and then prove process capability. And then do a risk assessment update, as I mentioned before, in the final phase of risk assessment. You update that and then hand over to production. So this is where your scope ends as a project engineer or the process planning engineer, right? Then we enter into project management phase 3. So any questions until now? I'm almost done. I don't want to take more time of you. I know it's the last session for you.
Yes, sir, there are a lot of questions from attendees.
Okay.
So Professor Raghuraman asked that project management for a process industry or job layout based industry like ship, aircraft, etc. is a very complex job. So how does the undergraduate student prepare for it, sir?
So as I said, like, see, directly you won't be going into a complete project management scope from the beginning to the end, right? You'll be given a a part of project management. It depends on what your interest is, what you studied before, what kind of experience you gained, right? So in this example, as I've given, you're basically focusing on process designing. You'll be going as a process planning engineer or process engineer, right? And then do only that portion. Or you may even get only the design portion. For example, in some industries, you may just design a part, right? Like, for example, a small gear or a pinion. You just design that, and then you do CNC machining process, and then bring it back. So that kind of small scope you will enter into, and then grow bigger, right? So that is a good way of growing too, right? You will know the field level, like ground level reality, and then move forward, and then you will gain more experience, right? Instead of just taking the whole project management and then not knowing what exactly you're doing, right?
Yes, sir.
I hope I answered your question.
Yes, sir. Yes, sir. So
Okay.
there's another question from Ajay Kumar that
Yep.
if you want to start an e-vehicle startup, is there a kind of ideal flow chart or a business model that we can follow from beginning to the final product?
Yeah, I mean, is it for setting up an industry or
Yes,
is
sir.
it for how to run the industry, like how to manage the shop kind of thing?
Sir, we can focus more on a management part for this question.
Okay, so generally, I'm sure you should have studied by now, like a VSM and VSD, like value stream mapping, value stream design. So if they focus on that initially, like during a startup, that would really give the whole picture. So I just want to quickly go over that VSM and VSD. I know if most of you guys might know. So value stream design, right? So basically, before setting up any industry, you basically put as a design, like from what are all your vendors or suppliers, and who you are as a production company, who you are, and then whom you're going to sell the products to, right? So you have three phases, and then you will have all the routes, like how you will bring the part from supplier, like for example, road or by air or whatever, and you have all the times listed down. I'm pretty sure you have seen that process, value stream design. And so once you lay out that value stream design and see, okay, this is how I want my industry to be, and then you start building, basically you start building on that. And then there are like tons of materials or the principles available from even Toyota principles, right? There are a lot of companies who adopt that and then try to set up their own shop, right? And then once you do that, you just basically do the value stream mapping of the current process, like just to compare with your design, right? I planned this design, and then I did this, put up this shop, and I'm just comparing whether I did what I planned, right? You may end up in a different thing. Just improve from there on.
Yes, sir.
Excuse me, sir. What are the FMEA techniques used for risk assessment in your company?
So here in risk assessment, basically, for let's say for this equipment that I was mentioning, like the assist. So it's more like where it will fail, how long, more focused on the team member, right? Team member safety. So we focus only on that aspect, right? It's not like a design FMEA that project engineer will be doing. So design FMEA is more onto the vendor side. So he will, in his design, he will say, okay, if I make this radius R6 or R20, whatever, right? And what will be the impact on the product side? So he will be doing that design risk assessment. But as a project engineer or a project manager, what you will be focusing on is the team member aspect, right? Let's say if the team member is picking up here and then dropping it in a 70-degree angle, will that be a problem for him if he operates for let's say half a shift, right? So I'll focus only on that element, right? And then let's say, for example, the push button, right? He has to operate the push button for 4 hours. So what will be the load on that push button? Like it should be like less than 1 kilogram load to push that button. So that kind of details will be there in the risk assessment in our purpose, right? In the example that I was mentioning. So is that the answer that you were asking, or did I understand your question right?
It's closest. I don't think it is exactly correct. Okay, thank you, sir. Thank you.
Okay.
Okay, sir. Next question from Raj. He says that, sir, as we all are aware that Toyota and their management techniques are one of the most refined, Can you please share a real-time problem that you faced and how you overcame that? Basically, the kind of organization pitfalls that you consider.
So, see, as a project, if you take, like, there are a lot of challenges you will be facing. Um, any equipment, right? Any small equipment you take, you will have like 100 challenges. Like you follow this checklist, you follow this process. It doesn't matter. Like you will end up like, okay, this design will not work, right? So one example is I wanted to design a equipment where it can lift a big skillet. We call it skillet, where the vehicle goes onto. It's like I would say 10 feet by 8 feet, steel structure, right? Steel platform. So you need to basically pick that platform. It weighs like 3,000 kilogram, right? You need to pick that with a crane and then drop it onto a table where the maintenance guys can go underneath and do some checks, right? Basically checks for sensors, checks for wheels and all those things, a regular activity, right? Preventive maintenance activity. So let's say I designed the whole equipment, we measured everything, we did the field checks, we put on the design, the vendor came in, they measured everything. So at the end, what happened is in their design, they mismatched by 1 foot, like the whole big area, that fence that need to go around that. We constrained everything, and then there was an aisle where the product handling, tow motors and everything used to go, right? So we cannot occupy that aisle. So we got permission for a certain extent, but they extended by 1 feet, right? It has to go into that aisle. So now you, as a project manager or project engineer, you need to go get the buyoff from your team, right? Now you know product is made, it is going to be like 1 feet away. You have no other thing to do. Now you need to find a way where the other process is not getting affected. You need to go discuss with your stakeholders, make sure you find another alternative for the other side, like the aisle, and you basically take that as a small project and do that thing, right? It keeps on growing. So for each and every aspect of your project management, you will have pitfall, you will have problems, um, and you need to be open to find solutions on that.
Yes, sir. Sir, another question from Santosh. Can you please elaborate on FSD, functional specification document, and what a typical FSD should convey and mandatory points to be added, sir?
The functional specification, right?
Yes, sir.
So any specification, as I said, the first thing is your constraint. What is your constraint and what do you want? For example, I'll go even basic stuff like buying a TV, right, for your home. You're going to mount it into a wall, right? So what is your constraints? What is your wall size? What kind of size, or what size of TV you can mount it there, right? So you basically start with that, and then what quality of picture you want, and what kind of cables you want to connect to that, and what you'll be doing with that. So basically, you are not telling, okay, this is the TV I want. You're not telling the TV manufacturer, this is what I want, but you are basically writing, this is what I want, and you will basically look around and see what TV matches that, right? So that's what should be in your functional specification. So what you want for the team members who is working in the shop, what they'll be looking for, and you're basically writing that as a spec and providing it to the vendor to make that equipment for you.
Yes, sir. So another question I think you covered in the slides also, that what should be the general framework in case of mass customization in automotive sector, sir?
Sorry, I didn't get the question. Sorry.
Sir, what should be the general framework in case of mass customization in automotive sector?
Mass customization. So you mean, can you elaborate that question a little bit? Like what exactly they mean?
I think she means how can we choose the design on if there has to be a modification on a later stage of design. So
Okay.
like if we have to customize some parts later, I think that's what she means.
Okay, so basically you have a design and later on you have to change it.
Yes, sir. Some customization is required.
So
may
yeah,
I interrupt here? Actually, mass customization in the sense, once the product is launched,
yeah.
we found that there is a failure, and all of a sudden we have to change immediately. In such a case, what will the solution for that?
Okay. Yeah. So I'll give you one example from Bosch when I worked there. So let's say we did a relocation project. Basically, like we wanted to build a assembly line from. There was assembly line in Germany. It was completely automatic line, and we had to build a manual assembly line, right? But it has to make the exact same product. It's a very small product. Product handling was a very challenging task, right? So in automatic machine, it's so easy. Like you can program robots, and then it can just pick the part and then do the resistance welding, and then comes out, right? So in our case, we had to handle with hand, and that part has to stay in that spot during the resistance welding process. So the team member cannot touch it when the resistance welding process is happening. So there should be some kind of small jig that we had to make. So we did all the same kind of process. We gave the constraints, we got the final jig, and it did not work. So basically, at that point, it's like fighting for a jig at that right time, right? If you don't have it on right time, you cannot deliver that project to the next customer. So basically, at that point is where you have to sit together. You have to sit down with the vendors, or you can. What I did basically is I designed my own jig, right? I know the product. I designed my own jig. I designed the process. Basically, like I used a wire cutting process to get that small part held in a right spot, right? You will have to do that in many aspects. Even for this assist that I was mentioning, we bought it from Japan and we brought it to Canada and make it work. So basically, I have to tell them what all we have in the shop, and they will make equipment in Japan, which is completely off location, and we have to go there, buy that equipment, and put it in our shop, and it won't work. And there was a guide that they made where the assist, they'll pick the door and then they drop it onto a conveyor, right? So when they drop it onto the conveyor, they have to be exact and precise and drop it onto a pin, right? So that guide that they made, assuming all the numbers that we gave, the structural elements are completely different, right? In reality, so we had to do a design ourselves. Like we had to do a design ourselves. We had to fabricate from scratch. It may not be a process where you do everything in AutoCAD and then make a part and then install it, right? You just do hand sketches, you do some tryouts, make it okay. You do a trial and error and then get it done. And then formalize it with the design and then formalize it with the FMEA and stuff, right? So that's how majority of the project will go like.
Yes, sir. So there's another question from Sohan, that
Yep.
how do you identify the weightage given to a particular stakeholder in the project?
Yeah, so weightage. So when we do the phase one of the project, right, there may be some highlights on the stakeholders, right? So in our case, let's say in Toyota in project management, where I'm dealing with, my stakeholders are production team members, right? Production team members, production group leaders, managers, they are my stakeholders. I'm going to give the equipment to them. So they will be my stakeholder. And then another department that you will take is the safety department, right? So they will come and check the safety of the equipment. So in any thing that you're writing a spec or you're having any meetings or anything, you need to involve your stakeholders in every phase of the project. So you cannot do something in isolation and then just finally go and hand over this product to them. So you'll be basically working together from beginning of the product, right? From the feasibility study until project is done, you all will be working together. So stakeholders, I'll give a small list. So first thing will be engineering department of whoever you're working, and their production management, and their safety management, and their maintenance team. So all these will be for a manufacturing setup is what I'm saying. So you need to take all the key department and then keep them involved. So there will be a pilot team usually. So in our case, how Toyota is set up is we as a project organization is a separate small team, and the whole production team is different. So there's production engineering and this is project engineering, right? So we interact with production plant, and we'll take one, they will decide one pilot person from every department and then allocate for that project. So anytime this project team calls for a meeting, they have to be present for that meeting and they have to share their thoughts, because they are the one who are going to use the product, right? So it is like an integrated process. It's not like one particular phase you go and talk to them.
Okay, sir. Sir, there are some more questions, but we are limited by time, sir. So
Yeah.
I would like you to just conclude the rest
Yep.
of the presentation, and if
Sure.
the rest of follow-up question, they can contact you directly, sir.
Sure. Yep. So quickly, I'll go the phase 3. So we came to the phase 3 of the project. So we'll be handovers, basically submittals with all the design drawings and open items, manuals. We submit to the production, and we support for 1 year usually. Any kind of issues, as one of member was mentioning, you will have some issues later on, not only just during install, but after install, there'll be a big issue like safety issues, right? Oh, this team member got their hand cut because of your equipment, right? That's how they'll come back. So, and then you have to go and see, okay, what exactly went wrong, whether your design had a problem or the team member did the problem. And there may be sometimes you did not plan something on a safety aspect and something would have really gone wrong. So you basically go and fix that. So that happens until 1 year of the project. And once that is done, you compare your budget plan versus actual. So in phase 1 and 2, what all budgets you planned and what you ended up, you have to compare, and then you close the budget and the project is closed. So that basically you had a start point and now this is a close point of a management project. So that's the whole project management and the design. General comments to future engineers and managers. I just want to give you some highlights. So respect for people is the main pillar of Toyota. So it's like nobody is king of everything, and it's a learning process every day. So respect for people is a key thing. Once you start doing that, you'll have a good working relationship with everyone. But that's very important when you go into any industry. Second thing Toyota follows is safe work is the door to all work. So whatever you design, whatever work you do it safe and make it safe for everyone. That's a very prime responsibility of an engineer. So do that. And work ethics and attitude it comes before everything. So you know 100 things technically doesn't matter. Your work ethics and attitude and willingness to learn, right? A little bit of technical knowledge and willingness to learn will take you a long way. So just a few comments I want to mention. If you have any questions and comments, please, we can go now, or if you do have run out of time, you can always contact me directly.
Sir, yes, sir. If you can share your email address in the chat box, sir, so that attendees can contact you, sir.
Sure.
And now I would like to switch to Reynolds, sir, to give the concluding address.
Sure.
Yeah, thank you, Karthi, for your wonderful talk. I do really appreciate the commitment that you have shown from the beginning. So we had a lot of clearance issues from your managers from your industry, but you came across all those things, and you really your dedication towards presenting this session. I really hats off for all your efforts. We really lost many people due to the clearance issues and other proceedings they have to follow. Many people were not able to make, and we would have got another 1 day of workshop. So many issues were there, but no, you were able to really uh, apart from others. The details that you shared during the session will really help people from academia to have a good idea of how industry people develop their products. You gave a very good insight about how you people work and what are the things that are required. Even though we study them in bits and pieces, you just stitch them everything together so that all the budding engineers as well as faculties who are new to academia, they'll be able to learn all these tools. So whenever they are going and explaining these concepts to the future engineers, it will be a very good eye opener for them as well. And it's I presume all the students who are attending this workshop who are planning to sit for their placements, I think the students should have got a good idea about what industry or what the people from industry who are coming to recruit you, what is their expectation from you. And finally, the advice that you gave, it is a very good advice. But today's in today's years, people they never like advices. But no, the advice was really very good.
So it's not advice. It's just like what I learned over time. So I just wanted to share with all my friends.
And I really thank you for this wonderful presentation, the efforts that you made, and really hats off once again. Thank you, Garthi, for this wonderful presentation. Looking for more such wonderful presentations from you in our future events as well. Thank you once again.
Thank you very much. Thanks for giving me the opportunity. I really liked it. So hope this helped at least a few students, right?
Yeah.
Yes, sir, definitely. Thank you, sir.
And I think we can go for the valedictory function. I call upon our HOD sir to join the function, as well as I think few of our participants, if you can just share your comments. What are the
Yeah, I'm looking into the comments. Many want the PPT slide. So I will send it to you. Maybe you can circulate to everyone. Is that okay?
it's up to you, Karthi, because there are other presentations which there are many confidential data which were
No,
presented.
I'm okay with sharing. So
If you
I
are
just
okay
want
with
to
sharing your
know how to.
comments, we will be able to circulate them. So we request all the participants to send us a mail so that we will be knowing who's willing to get these presentations. I think we'll be able to share Karthik's presentation, but all the other presentations, it's really confidential. So it is really tough to share those
Yeah,
things.
I
So
can share my presentation to everyone. So no issues. All I need to, I mean, I don't know everyone's email ID, so I'll just send it to you. You
yeah.
can share to everyone. So I'm okay with that.
Yeah, yeah, yes. And participants, you can unmute yourself and you can just tell a comment on any feedback on how no the workshop went and any improvement that is required, anything that is missing. You can share your comments. There are 114 participants. You can just share your comments, or you can just raise your hand so that I'll try to unmute you. Uh, Okay. So, Savitosh, can you help me in?
Yes, sir.
I'll make you.
The-
I'll make you as the host. Can you try and check whether you can unmute others? Now you are the host, Savitosh. And whether HOD sir is there, I will try to contact him.
Yeah, I'm there. Yeah, I'm there. Professor Reynolds, I'm there.
Sir, he is there, sir.
Yes, sir. Sir, participants are commenting in the chat box that it was a really good session. Ajay Kumar wants to comment. I have unmuted him, sir.
Hello, sir. Good evening to all the dignitaries. And I would like to say that it was a really good webinar, and it was really informative things that I came to know. I am from academia myself, and I think I came. I learned a lot about the industry, which I never actually knew while being in my college. I would like to express my thanks to VIT and the faculty members who organized this event. I would like to uh, stay connected for more such workshops. Thanks a lot.
Thank you, Ajay. Thank you.
Hear me?
Sir Mohammed has commented that thanks to the organizers for giving this opportunity to learn the technical ideas through this wonderful workshop. And Bhupati has requested to share the PPTs with him. So we'll do that. And everyone is thanking. So over to you, sir.
Mute.
Professor Reynolds, unmute yourself.
Yeah, yes, now I can unmute myself. Actually, I made Savitosh as the host, so I was not able to.
No, okay.
Okay, I think we can close the session. Like we
Yes,
can
the session
initiate.
is closed. We can do the validatory function. I like to give a vote of thanks. And before that, if HOD sir, if you can share a few words about the workshop as well as the take home of the participants, it will be a great.
Yeah. So, good evening. I'm once again thank you so much for all the speakers who are involved in this workshop. Since from yesterday and today, yesterday we have covered around 5 keynote sessions, and today we have covered around 6 keynote sessions in this workshop. It is having a combination of product design and how the materials should be selected and what is the importance of the material, how the failure is going to happen, and also along with this, today Mr. Karthi Punyadas has given from excellent presentation. We always give a lot of there is a lot of respect to your always quality is a matter. Okay. So really, sir, appreciated your excellent presentation towards, especially in the area of project management in the assembly lines. And overall, the sessions are very good, and I really appreciate the coordinators, Dr. Srinivas Narayanan and Professor Raghuraman and Professor Renald Elson for their, it is since from long time they are working on this, and finally, very good speakers. They arranged the workshop in a very systematic way. And once again, I thank to all our management and our deans sir for providing this, giving permission to especially to organize this international workshop. So from this, once again, I thank to all our participants, not only from VAT, even other faculty and students are participated in this workshop. I hope totally around 600 participants are there. But finally, it went very fine, and it was very useful. From this, from my side, I congratulate to the organizers. Thank you so much.
Thank you, sir.
I'll just give the vote of thanks and we will complete this workshop. And it gives me a really privilege to organize such a wonderful event with all my fellow coordinators. So Dr. Srinivasan Narayanan and Dr. Raghuraman DRS. So it was a great journey. It was a 3-month journey. We really had a lot of plans, and we are really happy that we were able to execute this to our fullest satisfaction. And I really wanted to thank our Chancellor. He is a good inspiration for us, and also VPs and AVPs, ma'am, and Vice Chancellor, Pro Vice Chancellor for always being a support to us, and the Registrar. And I like to thank our Dean, School of Mechanical Engineering. He was always guiding us and giving us the proper directions. And I also like to thank our HOD Mallikarjun sir. So whenever we faced an obstacle, whenever we hit a roadblock, he was there. He was saving us. He was really guiding us. So really, thank you, sir. Thank you, HOD sir, for really. There were 2 places where you really helped us out. You bailed us out. Thank you for that. And next, the most important thing, I like to thank Mr. Savitoj and Dhanush. They are a wonderful student, and they really helped me in organizing this event. They really handled the sessions really beautifully. We have really become your fans, Savitoj and Dhanush. Thank you.
Thank you,
And
sir.
really, participants, you are participants. Really, we had a very good quality participants, and no, we had lot of checklists. We had lot of quizzes and anything. And out of 500 registrants, we had solidly 120, 130 participants. They participated throughout, and they really asked good questions, really very quality questions, and they really submitted the feedbacks as well as the quizzes. And I really, we like to appreciate the participants. We really, we extended all these things, and I really thank all. And but not the least, I'd like to thank the system admin Gopi sir. No, he really helped us in arranging the Zoom meeting. He really taught us all these things. And of the most speakers, they are the pillars. I have to thank all the speakers. All the sessions were really world class, and I like to thank everyone. And with this, I'll close the session, sir. And we have given the feedback forms. Kindly fill the feedback forms. So there is no, I think Srinivasan sir, I think you have given questions in that, I think so. Once again, so kindly fill the feedback form, and you give us 2 weeks time so that we'll be able to process all this, and we'll be we'll be starting to give you the virtual certificates as soon as possible. Just give us 2 weeks time. And other than that, everything is fine. Thank you. Be safe. That's from our end. Thank you, sir.
Thank you,
Thank
Mr.
you.
Karthi. We'll be in touch with you. Thank you. Thank you so much.
Appreciate that.
See you, sir.
Have a good day.
Bye-bye.
Be safe.
Yeah, sir. Savitoj,
Yes, sir.
Savitoj, you have to make me as the host, Savitoj. That's why I was not able to do anything.
Okay.
You have to make me as the host. Yeah.
Yes, sir. I've done it.
Okay, now I am the host because I have to